This is the Dell Precision Tower 3620. It's a desktop computer, but it's got something special. First of all, it's got a Quadro K2200, which is an 11-year-old professional graphics on. Second of all, it's ugly. Yeah, I just don't know what to say about this, so I said this. But anyway, let's talk about it a little. So this computer was manufactured by Dell between 2015 and 2020. It used to come with Windows 7 or Windows 10. Back then, it would have cost you between $729 USD and $2,329 USD. So those machines weren't cheap back then, but don't forget that I took the lowest configuration ever and compared it to the highest. But still, if we adjust to inflation, it's worse. Anyways, they were meant to be used like professional grade workstation for tasks such as scientific and engineering applications, digital content creation, CAD and 3D modeling, software development and testing, financial modeling and data analysis. All of that makes me want to say, damn, this computer was good at Blender and Excel. And you might also think they need some special security treatment. And you'd be right, because Dell included their own TPM/RED supports for critical mission environments. So those machines, they were like safe certified. But then you ask, but Yannick, what's TPM or RED support? Let's start with TPM. First of all, it stands for Trusted Platform Module. So that already gives us an idea that the computers are protected. How does TPM work? Well, TPM encrypts certificates and passwords securely. It's also a BitLocker encryption. What does that mean? It means that it enables full disk encryption. It also lets you secure boot. That means that it ensures that the system boots using only trusted software, in that case Windows, and it's a platform integrity. TPM can detect unauthorized changes to the system, preventing tampering or malwares. So yeah, basically TPM is one of the kings in that computer. But what about the other king, RED? RED stands for Redundant Array of Independent Disks. Wow, what the hell is that, dude? You might ask, and such as usual, I'm going to answer. First of all, there are many types of RED. I know. It's already hard with one type, but many. Don't worry, I'm going to explain everything. There is RED 0, which uses striping. Striping offers improved performance by splitting data across multiple drives, but no redundancy. That basically means if one drive fails, all data is lost, so basically a RED 0 is useless. Then there is RED 1, which uses a process called mirroring. Anyways, mirroring. It provides redundancy by duplicating data across two drives. If one fails, the other retains all data. Now that's way better, right? You understand why it's called mirroring. Then there is another RED. That's not a joke. You thought RED 1 was enough? You'd be wrong, my friends. There is RED 5. And what does RED 5 do? Well, it simply uses the striping process and the power type process. We know what striping is, but what about the power type process? Well, first of all, it requires at least 3 drives. Yes, 3 drives. It balances performance and fault tolerance by distributing power type information across drives. What the frick did you just say? Alright, let me break that down. Basically, RED 5 spreads its data onto the 3 or more drives, but it also uses the power type process. The power type process basically rebuilds the data if a drive, let's say, fails or dies. How does it do it? A drive just died. Yes, I know, it seems impossible, illogical, stupid, but it can, because the power type process uses the remaining data and tries reconstructing it. That's how it does. How is there remaining data, you might ask? Because don't forget that RED 5 spreads all of its data on the 3 drives or more. And that's how RED 5 works. But that's not the last one. No, that's not the last one. The very last one is, you guessed it or not? RED 6, RED 7, RED 8? Nah, those don't even exist. RED 10. RED 10 uses the best process, which are mirroring and striping. I know earlier I said striping is useless, but you'll see why it's not. I'm going to explain it very quickly, because we already talked about it. Basically, the striping process offers improved performance by splitting data across multiple drives, but there is no redundancy. Then the power type process, as I said, it reconstructs the data if, for instance, a drive fails or dies. It uses the remaining data because it had spread all over the minimum 3 drives, and that's RED 10. Now, let's get back on the main subject of that video, the Dell Precision Tower 3620. What process does it use, you might ask? Well, the Dell Precision Tower 3620 uses the TPM process, and it uses, depending on the drive, all the red processes. I have a Dell Precision Tower 3620, but I only have two drives, an NVMe and an HDD. So in theory, my computer uses the red one. In theory! Now some specs. The Dell Precision Tower 3620 came with all of the 6th core generation processors by Intel and a little of the 7th generation. For instance, Intel Core i3 6100 or Intel Core i7 7700K. There were also Xeon CPUs such as Intel Xeon E3 1220 V5 or the Intel Xeon E3 1245 V5. If you want to see the specs of all the CPUs that were disponible on that computer, it's on my website, which is https://computer-reviews.versal.app. Link in the description. And let's say the website is constantly in construction, so it's kind of ugly. Sorry. But anyways, what about the GPUs? All of the factory configurations were Quadros, NVIDIA Quadros, such as the NVIDIA Quadro K420 or my GPU, the NVIDIA Quadro K2200. There are more, but you know where to find them on my website, https://computer-reviews.versal.app. Link in the description. What about the RAM? This computer has 4 slots of DDR4 RAM. No matter how old the model is, you can expand it to 64 GB, no more. What about the I/O? So on the I/O, I'm just going to talk about the motherboard because it would be annoying to check every single GPU that came with that computer. I can tell for the Quadro K2200 if you want 2 display ports and a DVI. But anyways, the motherboard. There were 2 1.2 display ports, an HDMI, I don't know the version of it, 2 PS2 ports, the console, the keyboard and mouse, I see you console players, a serial port, including the front I/O, 2 inputs and 2 outputs audio jack, including the front I/O, 4 USB 2.0 ports, including a charging one, again, including the front I/O, 6 USB 3.0, an RJ45 port, and of course the power cable entry. Why don't you see the inside of the computer? I'm gonna show you. So, the computer. Don't ask about that. That's my mounting bracket. So, here we have a 2015 HDD, an NVIDIA Quadro K2200. There, the Intel Core i7 7700K, 24 GB of RAM. This one is 16 GB. This one is 8 GB. Alright, there we have the DVD/CD/CD rewrite/DVD rewrite player. Here we have a 350 watt PSU, and I think that's it for the computer. Yeah. Oh yeah, here we have the NVMe. Let's take it to some benchmarks. I'll do Cinebench R23 benchmark and Silver benchmark.
subscribe, and I'll see you guys later. Bye.